Good morning students, I am Vettichelli from again Vetti and Vetti NEET coaching. Today I am going to give the important question from the lesson of Redox reaction. Question is, for decolorization of 1 mole of potassium permanganate, the mole of hydrogen peroxide required is here 1 by 2, 3 by 2, 5 by 2, 7 by 2. This is the question from AIMS 2004. So this is the method of important question we are expecting for the tomorrow's NEET exam. Okay, now let us see. For this question, you have to approach the equation. The new trick here: potassium permanganate with hydrogen peroxide in the acid medium. The medium is not represented. You take it as an acid medium. Permanganate is ended as the Mn2 plus, and hydrogen peroxide on oxidation it gives the oxygen. So this is the reaction where you have to find out the N factor. Permanganate with the +7 oxidation state is reduced to +2, whereas hydrogen peroxide, where oxidation number of our oxygen is -1 to 0. So now that is where -1 to 0 is getting oxidized. For this, first you have to write the equation. Then you have to find out this pattern where you are writing name of the reactant: potassium permanganate, hydrogen peroxide. In potassium permanganate, next heading is change in oxidation number. This method is new. Please follow it. Change in oxidation number. Permanganate here is +7. Here it is +2. So +7 to +2, the change is only 5. So here you are writing the change in oxidation number. Next you have to write for hydrogen peroxide. Same model. Here hydrogen peroxide is -1 to 0. So this is for 2x. 2 oxygen, so 2x. That is 1 oxygen, it is 1. So for 2 oxygen, 2 into 1, it is the 2. Whereas in the case of oxygen here, 2 atom. So here it is equal to, for 1 atom it is 0. 2 atom, 2x is equal to 0. Now what is our next work is, find out the difference between these two. So the difference in the change in oxidation number is 2. So here you are writing, here hydrogen peroxide change in oxidation number is 2. Next you have to write cross multiply. This 2 you have to write here and the 5 here. You after writing the 2, write 2 mole of same reactant, potassium permanganate. Here write 5 mole of hydrogen peroxide. So what is this indicating? 2 mole of permanganate. Now let us see here. 2 mole of permanganate required to react with 5 mole of hydrogen peroxide. This is the statement we have created. Next let us see the question. For decolorization, 1 mole of permanganate require how much mole of hydrogen peroxide? This is the question. So for 1 mole. Now let us see here. This is for 2 mole of permanganate is 5 mole of hydrogen peroxide. Therefore, 1 mole of permanganate requires equal to 5 by 2 mole of hydrogen peroxide. So this is the answer, 5 by 2. Let us see the option. Here option is C. So this is the way you have to calculate the number of moles required for the hydrogen peroxide. Let us see one more question. So this is the question. Here the question is number of moles of permanganate required. Put the question mark. Permanganate required to oxidize 1 mole of ferrous oxalate completely in acidic medium. All are given acidic medium. Permanganate is required for 1 mole of ferrous oxalate. So you should think about the ferrous oxalate. AIMS 2008. So next level of toughness. Here let us see the solution. How you have to do it. Write permanganate with the oxidation state +7. Ferrous oxalate. Here the formula for ferrous oxalate, acidic medium. As usual, acidic medium, the permanganate is reduced to your Mn2 plus and your oxalate is oxidized to carbon dioxide as well as your ferrous to ferric. Now let us see the same pattern here. Reactant. What are the name of the reactant? First you are writing the permanganate. Then what is the next heading is change in oxidation number. Here this +7 to +2. So the difference is 5. So here you are writing change in oxidation state of your manganese is 5. Then coming to the ferrous oxalate, you divide into 2 categories. One is ferrous ion, where it is oxidized from plus 2, 2 plus 3. So now the difference in oxidation state is number 1. Now let us go to the next ion is the oxalate, where the oxidation state of your carbon is 2 carbons equal to 6. It is oxidized to your carbon dioxide, where the oxidation state of your carbon dioxide is plus 4. Now what is it? 2x is equal to 6. Here x is equal to 4. So what we should convert is 2x. So 2x is equal to 4 into 2. You are getting 8. Now since it is for 2 atom, you have to calculate for 2x and 2x keep it. Now the difference is 8 to the 6 is the difference is 2. So now for ferrous it is 1. For oxalate 2. Together it is having the 3. Now let us go to the cross multiply. So this one you are writing here. For the manganese you are writing. So after completing 3 moles of same reactant you have to write. Permanganate. Here 5 moles of your oxalate. So what is indicate is therefore 1 mole of oxalate is equal to 5 moles of oxalate is equal to react with 3 moles. So now here writing is 3 moles of, now I am going to write again 3 moles of potassium permanganate consuming or required 5 moles. Question they are asking how many numbers of moles of permanganate required for 1 mole of ferrous oxalate. Here ferrous oxalate is how much you are ferrous oxalate you are getting 5 mole. They are asking for only 1 mole. So I am writing here 5 mole of oxalate requires 3 mole of permanganate. So therefore 1 mole of oxalate required 3 by 5 mole of permanganate. This is the your answer. Let us see the option here. Here it is in the form of fraction. So now let us coming to simplify the 3 by 5, that is equal to 0.6. So now the answer is 0.6 moles. So this is the way you have to approach the sum. Again I am repeating. First you write the equation and then write the name of the reactant, change in oxidation number. Here trick is you have to divide this thing in the 2 categories. One is ferrous changes to ferric, oxalate it is 2x to the carbon dioxide x. So together it is coming as a 3 as the n factor. Now write the n factor in a cross manner and you are approaching like this. So this pattern is very important question children. Be confident, be positive and all the best for tomorrow's exam. Thank you students.